Course 2, Lesson 20, we're going to be talking about exponents today and area and square roots. So we're going to jump right in and look at an example of exponents. So if you have 2 squared, this right here number is equal to an exponent, which means 2 times 2, which is equal to 4. So if I have 5 times 5 times 5 times 5 times 5, if I show that in exponential form, I just count up how many 5s I have, which is 5. So it's 5 to the 5th power is my answer. I could also figure this out, but shorthand demonstrates those opportunities. Okay, so in your example 1, A says to simplify 4 squared. What is 4 squared? Well, that means 4 times 4 literally, and it's 16. That's easy. B says simplify 2 cubed. 2 times 2 times 2, excuse me, is equal to 8, right? 2 times 2 is 4 times 2 is 8. C says 10 to the 5th power. All right, how do we do this? Well, I can tell you that if you write it out, 10 times 10 times 10 times 10 times 10, all these are being multiplied. What I like to do, we know it's going to be a 1, and then I count zeros, and if there's 5 zeros, oops, it's 100,000. Should be an extra 0 there, sorry. 1, 2, 3, 4, 5 zeros. It's 100,000. Okay, and then D, again, pretty easy. This shows a fraction, so it's 2 over 3, and then this is squared. So that means 2 over 3 times 2 over 3 equals 4 over 9. So all of those are relatively easy answers. Okay, look at example 2 where we have 4 squared minus 2 cubed. How do we do that? How do we solve this problem? Well, we have to come up with the real numbers. So 4 squared is 16 minus 8. Well, that's going to equal a total of 8, right? 16 minus 8 equals 8. All right, so not too difficult as far as that's concerned. Example 3 gives us something that's a little bit unique. 2 cubed times 2 cubed. What does that equal as far as our number? And it says 2 to the n power. We want to find out what this means. If we have something that is being multiplied, just like this right here, we add the exponent. So it's going to literally equal 2 to the 6th power, because 3 plus 3 is 6. That's when numbers are being multiplied. When you're adding or subtracting, you don't do that. You just add and subtract the actual number. The opposite is true when you divide. So let's say 2 to the 6th power divided by 2 to the 2nd power. What does that equal? Well, if we move this expression up to the top, or we move this exponent up to the top, it becomes a negative 2. And we know that 2 and 2 is like equal to 1, right? So we could say that it is 2, 2 to the, and if we move this up to the 4th power, sorry, I can't think for a second, okay? Because 6 minus 2 equals 4, okay? And so we're moving this exponent up. That's all that we're doing. We're just changing that exponent to make that happen. Here's another way to think about that problem. Okay, in your textbook it gives 2 to the 6th power over 2 to the 3rd power. You can do this: 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Okay. And then 2 times 2 times 2, all right, to the third power. So if we did this and we wanted to demonstrate what we have left over, we can cancel off that many 2's. What are we left over with? We're left over with 3. So that would be 2 to the third power. Okay, so you can write it out longhand like that, and some of the problems ask you to do that. Okay, let's go to the next section, talking about area of a rectangle. So I'm going to build a rectangle here, draw a rectangle. Okay, excuse my inappropriate sides, they're not always perfectly straight. Anyway, let's say that this is 10 and this is 5. What is the area? Yesterday we talked about perimeter, the outside, but I want to know what's in the inside of this whole thing, right? Okay, so when I have that and I have a side, okay, and I have a length, I can say 5 times 10, which is going to give me 50. That means there are 50 units, right, in here that I could count, okay? So area is side times base, or base times height is how your text is going to give that, okay? So the example in 4, it says what's the area of the rectangle, and they give a rectangle that has 5 inches and 3 inches. Well, we're going to multiply both of those, which is 15 inches squared, okay? So it's just a simple multiplication problem, not too difficult as far as that's concerned. All right, pretty easy on that. Let's go to the last little section here and deal with square roots. Okay, square root, and I'm going to use the square root of 4 to start off with. What two numbers times each other equals 4? 2. So the root of 4 is 2. I want you to see something else. If I divide 4 by 2, I get 2. And notice those two numbers create 4. Same here. So the root of 4, or the square root of 4, is 2. In other words, I could say square root of 4 equals 2 squared, because that also equals 4, right? So anyway, 2 is our number, all right? 2 squared gives us 4, but the square root of 4, the very root of it, one of those little things, is 2. So in your textbook, they're going to give you all kinds of roots, okay? Square root of 121. What times what equals 121? Well, I know you're probably not familiar with it, but 11 times 11 equals 121. Once you start to see these square roots, you'll start to get familiar with them. Like 144, oh, that's the square root of 12. 81, that equals 9. 36, that equals 6. You're going to start to get familiar with all of these even roots. Here's another one, 64, 8. So you're going to get examples that look like this. So when you get a square root symbol, it's saying what times what equals that number, and we only want one of those. For instance, it's 12 times 12 equals 144, but the square root, meaning one of them, is 12. All right, that's your lesson today. Hopefully it'll be easy for you. If you have any questions, please ask.